Topic 3 is the addition property of inequality. And the good thing about this is we've already done the addition property of equality, and it works basically the exact same way. So this property allows us to move terms from one side of the inequality to the other side by performing the same addition or subtraction to both sides of the inequality. So if I add on the left, I have to add on the right. If I subtract on the left, I have to subtract on the right. Okay? Symbolically, we would let A, B, and C just be any real numbers. So fractions, decimals, integers, doesn't matter. If we can say that A is less than B, then if I take A and add C, it is still going to be less than A or than B plus C. Similarly, if we know that A is less than B, I can take A and subtract C, and it still has to be less than B minus C. Okay, this rule applies no matter which inequality symbol you use. So you could replace the less than with greater than, less than or equal, greater than or equal, and it would still work. Okay, so let's look at example 3. Example 3 says solve each inequality, write the answer in interval notation, and then graph the solution. In a previous video when we talked about interval notation, I said interval notation can oftentimes be the more difficult way to represent your answer. It's very common. You're going to need to know how to do it, but it sometimes is a little bit harder to figure out what interval notation is. So even if you're not asked to graph it first and then do the interval notation. So in this case, even though it says write interval notation and then graph the solution, I'll graph it first and then get the interval. Okay, so for part A, we have x plus 7 is strictly less than 12, okay? Just like with equations, we want to isolate the variable, and we isolate the variable by undoing what has happened to that variable, okay? So in this case, the variable has had 7 added to it. I need to move or undo that addition of 7, so I subtract 7. And if I do it to the left, I have to do it to the right to maintain that inequality. So on the left, 7 minus 7 is just 0. X plus 0 is x. And then 12 minus 7 is 5. Now, just like with equations, you can check your solution, but you have to be really careful. If I check this, I have to check values that are less than 5. Now, this says values for x have to be exactly less than 5. It cannot equal 5. If I were to plug 5 in, I would get 12 is less than 12, which isn't really true, okay? So I would need to pick any value less than 5. So we could say, let's check x equals 4, okay? 4 is definitely a value less than 5. Let's plug it into this inequality and see if it's true. So I would take 4 as x plus 7 is less than 12. 4 plus 7 is 11. Is 11 less than 12? Yes. Now, is it possible to check every value that satisfies this inequality? Absolutely not, because you'd be checking every single integer, every fraction, every decimal. That would take the rest of your actual life to check every value that satisfies this inequality, and you still wouldn't be done, okay? So all you have to do is really just check one value. Pick one value that satisfies the solution, and then just go from there. All right. Now, the directions say to write your answer in interval notation and graph it. I'm going to graph it first. It just makes getting the interval so much easier. So we draw a number line. We locate our endpoint. In this case, our endpoint is 5. So you just kind of decide where you want 5 to be. Now, the values for x have to be less than 5. So we want to put a rounded bracket on 5 because we cannot include exactly 5. So I'm going to put a rounded bracket on 5. And then I want any value less than that, which is any value to the left of 5 on the number line. So I've got my rounded bracket, and I kind of do a dramatic arrow just so it's really obvious which direction I've shaded. So this shaded region is your interval. The left-hand side of the graph is the left-hand side of the interval. The right-hand side of the graph is the right-hand side of the interval. So you can see the left-hand side is pointing towards negative infinity, okay? So rounded bracket, negative infinity. The infinities always get rounded bracket because in this case, it doesn't matter what we say we think infinity is, there's always something less than that. So you can never like include infinity. And then we want to go comma. So we're going to go negative infinity all the way to positive 5 without including the 5. So we would put a rounded bracket there. Okay. And that's it. That's how you solve a linear inequality in one variable. So part B, it's a slightly more complicated inequality. We do have variables on two sides of the equations. We have, inequality, we have constants on both sides of the inequality. So what we want to do is we want to get all of the variables to one side definitely the left, and then all the constants to the right-hand side. And I really, truly do encourage you to move your variables to the left with inequalities because you can get into some confusing situations if you keep it on the right. Okay, so I want to always wait to add and subtract to both sides of the inequality till I have at most two terms on each side, one variable term, one constant term. We're there. We have a single variable term and a single constant term on the left, a single variable, a single constant on the right. Now's the time to start adding and subtracting. So let's deal with our variables first. I want to move the 4x from the right to the left. Okay, that's going to get all my variables in a single term. That 4x, since it's positive, you could think of it as adding 4x to the, not to the left, to the right. So on the right, that 4x, it's positive. We would think of it as plus 4x. The way we would move it to the left is by subtracting it. So I'm going to subtract 4x from both sides of the inequality. On the left-hand side, 5x minus 4x is just 1x. We don't write the 1, we just write a single x. Don't forget your minus 4 or your greater than or equal. And then on the right-hand side of the inequality, we say the 4x is canceled because 4x minus 4x is 0. So they're gone, or they're not gone, they become 0. And then 0 plus 3 is 3. Now we have a situation where we have a single variable term, plus or minus some constant. So we need to get rid of that constant to isolate the x. So instead of having that minus 4, we add 4 to both sides, and that'll get rid of it. All right. So to isolate the x, I need to move the minus 4. I add it to both sides. Negative 4 plus 4 on the left is just 0. X plus 0 is just x. And then on the right, we got 7. So you could certainly check this. In this particular case, values for x have to be greater than or equal to 7. You could check 7 or you could check any value bigger than 7. So let's say we check x equals 10. Well, we would get 5 times 10 minus 4 is greater than or equal to 4 times 10 plus 3. Again, you could check exactly 7 in this case because the solution set does include 7. Or you could check any value, any fraction, decimal, integer greater than 7. 10 is greater than 7. I pulled it out of thin air. Let's check it to make sure it satisfies the inequality. You don't have to check inequalities very frequently, but every now and then it's nice just to make sure you're on the right track. So let's see, 5 times 10 is 50. 50 minus 4 is 46. We want to make sure that is bigger than 4 times 10, which is 40, plus 3 is 43. It is bigger. We're good to go. So let's graph this. So to graph it, you draw a number line and you locate your endpoint or your boundary point. So we're going to say our endpoint of 7 is right here. All right. Now I can include the 7, so I want to make sure I put a nice square bracket on the 7. That tells the reader that 7's included. And then I want to shade everything bigger than 7, which is everything to the right on the number line. Okay, so values for x are 7 or anything bigger than that. Now, the left-hand side of this inequality is the left-hand side of the interval. The right-hand side of the inequality is the right-hand side of the interval. So my inequality goes from 7 to positive infinity. Always put rounded brackets on the infinities. And this time we can include the 7, so we would put a square bracket. So that is practicing solving inequalities with the addition property of equality, or of inequality rather.